Forget frequently asked questions.
Common sense, common knowledge, or Google.
How about advice from a real genius? 95% of people in any profession are good enough to be qualified and licensed. 5%
go above and beyond.
They become very good at what they do, but only
0.1%
are real geniuses. Richard Jacobs has made it his life's mission to find them for you. He hunts down and interviews geniuses in every field: sleep science, cancer, stem cells, ketogenic diets, and more. Here come the geniuses. This is the Finding Genius Podcast
with Richard Jacobs.
Hello, this is Richard Jacobs with the Finding Genius Podcast and Finding Genius Foundation. I have Dr. Yael Joffe. She teaches nutrigenomics at Rutgers University. So we're going to talk about the science behind DNA-based dieting. So Yael, thanks for coming. How are you doing?
Good. Great. Thanks, Richard. Thanks for having me.
Tell me about your research, and then we'll fast forward to, at this moment, what you're working on right now. So a little bit of your history and then current research.
Okay. I started out in a slightly different place. I started out in architecture, and I changed over into a science degree when my grandmother died from cancer. So it was quite an interesting diversion for me to suddenly have to understand chemistry and physics. But I really wanted to try figure out, and this was almost like 30 years ago, why she had died from cancer, why no one had helped her, what she could have done differently. Anyway, I went looking for a degree in health, and the only one that I could find was actually dietetics. And this is dietetics in the early 1980s. And much to my disappointment, when I studied dietetics, it wasn't about health at all. And, there was a lot of like chocolate cake and ice cream and lots of sugar and refined carbohydrate and processed food. I was like, this is, wasn't what I'd signed up. So I finished my degree, but kind of was still looking for these answers, still trying to figure out how do you do things so that you can prevent these kind of diseases. And I was living in London when I met an extraordinary scientist, Dr. Rosalind Garrison, who started the first ever company in the world called Siona. And Siona was basically the first company to say that genetics and nutrition had this really important relationship that was going to determine the future of medicine. And being a dietitian, I knew absolutely nothing about genetics, but lucky for me, there were no other dietitians who knew anything more. So I joined Siona in 2000 and was lucky enough to work with Rosalind to build what was known as the first ever nutrigenomic report. So nutrigenomics, in essence, is the relationship between our diet and our genes. But it's actually quite a complicated relationship because there's two really important elements to it. So the first element is our DNA. That's our sequence. That's what makes us unique, or our blueprint. So imagine that we're 99.9% absolutely identical to each other, but at 0.1% we differ from each other. And it's this 0.1% that is really interesting to us. So why do we respond differently to the world? Why do we respond to calories differently, to toxins, to cigarette smoke, to alcohol, to food? Why is it that we can do the same amount of exercise and have a different outcome? This is really the field of nutrigenomics. Why am I different? And why do I respond to the world around me in a different place? We can understand that by doing a swab, right? We do a swab in our cheek, send it off to a lab, gives us results, and we're able to understand who you are. So it's about self-knowledge, understanding more about who we are that we can't always guess at. But there's another half to the work that I do, which is not just about what makes us different, but what can we do differently once we understand ourselves better. And the real aha moment for me that kind of was that full circle back to my gran was this idea that we could actually choose foods or nutrients or exercise or lifestyle practices that change the way our DNA expresses itself. So it changes our genes' behavior. And ultimately what we want to do is we want to switch on genes and we want to switch off genes, which is...
So are you talking about epigenetic change, or are you talking about actual underlying base pair change?
No. So you're 100%, it's epigenetic. So the first part I was talking about, we actually called nutrigenetics, which is what does my sequence read? What is my blueprint? And how does that determine how I respond to the world? And the reality is our sequence doesn't change in our lifetime. There might be one random one in an entire lifetime, but in essence, the DNA sequence we're born with is usually the one that we die with. But what can change is what you're referring to, which is epigenetics. And epigenetics is all about gene expression. And genes express themselves, genes behave in a certain way determined by what is happening in the world around them. And that is diet, that is lifestyle, that is trauma, it's stress, it's toxin. So that's the negative side of it, that if you're exposed to a negative stimulus like a toxin, it's going to cause a change in your DNA behavior that is going to have a bad outcome on your body. But the flip side of that is we can actually use nutrition and supplements and lifestyle to switch on genes that actually will have a positive impact on your health. And so when you put these two areas together, this is really what determines the relationship between our diet and our lifestyle and our genes.
So have you found a way to understand how epigenetic marks occur and modulate them with the right inputs, the right diet? Or like, where is all this knowledge going that you've gained?
So I no longer work in the research world, and I work in the translation world, which is, what do we do with the information? So I obviously used to do original research, but so where I work right now is building out the tests that you would do to try and understand how do you respond to your world and how you're different. And these are what we call nutrigenetic tests, which are the cheek swab. So a lot of my work is trying to figure out what are the genes that we should be studying, what kind of information do they give me about you, what kind of recommendations would I make, understanding who you are genetically. And the other part of my work now is not actually doing the research on epigenetic markers, but rather trying to build the more practical sides of things. So I'm really concerned with the fact that genetics for the last 20 years that I've been involved in it has been very data-driven, but with very little translation. So we've had like 20 years of all this amazing amount of genetic information, but end users, the clients, the patients are still not benefiting from how do we use this information in practice, whether it's a dietitian or a doctor, a psychiatrist, psychologist, chiropractor. What do we do with genetic? How do we extract value from it? And how do we change our decision-making based on this information? So actually the focus of my work has gone from very much research to more clinical application to try and say, well, what is the promise of genetics that's actually going to deliver?
So what are some clinical applications that you've figured out or in the process of working on?
So, there's quite a few interesting places to focus on, especially around disease prevention, but also disease management. But just something that's probably easier to understand is around energy, weight. So when I was a dietitian, I was taught that, if you ate the right calories and just the right amount, and then you did the right amount of exercise, you would always lose weight. Calories in, calories out equals weight loss. And I think we all discovered very early in our career that absolutely wasn't the truth, that there simply isn't an equation that says that this amount of calories is the same for everyone and that this amount of exercise is the same. So I was always fascinated by this idea that we were kind of setting people up for failure, that we said, like, if you do what we tell you to do and you don't lose weight, you're a failure, you don't have self-control, you don't have willpower. And when I started studying genetics, and my PhD was actually in obesity, I came to understand the extraordinary complexity of how the body manages calories, whether it's the calories going into your body, how we store calories, or how we burn calories. And that the variability of the individual and how all of us consume calories, how we eat, whether it's binging or snacking or not eating, how even when we expose to food, we behave differently, how we experience hunger differently and fullness. So we might all think that we are hungry in the same way, but actually we have completely different hunger from each other. And so I started learning that this whole kind of science that I'd based my first career on of dietetics was really actually something of a failure, because it really hadn't taught me anything about the people that were coming to see me and saying, I did what you told me to do and I'm not losing weight. And I was taught to go, oh, well, you must be lying to me. But actually the reality is that genetics is the most insightful and exciting way to understand who are you as an individual, how do you react to food in your environment, how do you eat, how do you store, how do you burn, and how do we build that into a diet and lifestyle that is really about you and is realistic and can help you rather than kind of the old-fashioned judgmental of calories in, calories out. That's just one example. There are many, many, but that's always the one that's easy to understand.
Well, can you give me a bit more specific? So you mentioned hunger. What does that mean? People experience hunger differently. Like, are there types of hunger, like ravenous versus peckish versus...
No, so it's more about the degree of hunger. So imagine this. So 5 of us, you, me, and 3 others, all stop eating for 24 hours. We haven't eaten a morsel of food. And we take ourselves off to the first restaurant that we can find, and we sit down and we start ordering. And we all discuss our hunger. But when it actually comes to eating, I have a burger and chips, and I'm actually done. My hunger is satiated. I feel fine. But someone else's table goes, you know what? I'm still hungry. I need another burger. Another one says, well, actually, I need 3 burgers. So the idea of what we think is hunger. So my hunger might be is a 4 out of 10, and yours might be an 8 out of 10. But we all feel hunger. So the problem with that is that when we built dietetics as a profession, we said there's a portion size for food. There's the right amount of food to make you not feel hungry. And if you eat that amount of food, you should feel full. But the reality is it doesn't work like that, because we all have a different hunger and we all feel full in different ways. So we could all eat 3 burgers. Some of us will feel extremely full and not be able to move. And some will say, like, you know what, I can actually, if I had to, I would have another one. So this concept that we all feel hunger in the same way, or that we all feel fullness in the same way, is actually not true. And it's genes that determine our experience of hunger. Does that make better sense?
Before we continue, I've been personally funding the Finding Genius podcast for 4.5 years now, which has led to 2,700 plus interviews of clinicians, researchers, scientists, CEOs, and other amazing people who are working to advance science and improve our lives and our world. Even though this podcast gets 100,000 plus downloads a month, we need your help to reach hundreds of thousands more worldwide. Please visit findinggeniuspodcast.com and click on Support Us. We have 3 levels of membership from $10 to $49 a month, including perks such as the ability to see ahead in our interview calendar and ask questions of upcoming guests, transcripts of podcasts you're interested in, the ability to request specific topics or guests, and more. Visit findinggeniuspodcast.com and click Support Us today. Now back to the show.
Yeah. Well, what about the genes change your hunger perception level?
So a lot of them affect hormones. So it's going to be leptin, and it's going to be leptin receptor, and it's going to be ghrelin, and so there's all these different hormones which are, biochemical messages that change the way our brain sends messages around hunger. And it's the same around fullness. There's a fascinating gene called FTO, which is, funny enough, called the fat mass and obesity gene. And what they found was that when people who had the gene variant, so a version of the gene, remember we're different at 0.1%, were exposed to a large amount of food. So imagine a buffet. Those that had the gene variant for FTO were less likely to be able to control their eating behavior around a buffet compared to those that didn't have a gene. So there was what they call a locus of control was lost, a loss of control when you were exposed. So those when you go to a buffet, you will go back 2 or 3 or 4 times, not because you're particularly hungry, but because there's something about the control when there's food in your environment. So
that's a pretty major change in behavior for some people versus others, because I guess when a person that would go to a buffet multiple times is around any food, they're probably more likely to get too much of it or have a lot more than other people.
Exactly. And of course, there isn't just one gene, there's multiple. So what we do is we study, in just say my panel that I've built, there's probably like 20 that I'm interested in. And say 10 of them are all telling me about eating behavior. So some will drive snacking, some will drive binge eating, some will drive locus of control. So we try and understand for an individual exactly what there is a huge amount of variance in why people behave differently about food. But what's happened traditionally there were different labels for it. It was greedy, it was lack of willpower, it was laziness. But no one turned around and said, actually, your genes are driving your eating behavior.
Okay, that's interesting. Yeah, it's a different way of putting it. So what are some of the top genes or actually manifestations of them? What are the top behaviors that are affected by, gene variations? You mentioned one that I guess, I don't know, they don't have a good sense of satiety, so they keep eating, or, what are the ones you've seen that are major modulators?
So one I've just mentioned now, which is around locus of control, others around fullness. So they don't get as full or satiated as others. And we see that a lot in children who just don't feel that fullness that their siblings might be having. We see it in hunger. We see it in how easily some store fat. So you might be eating the same amount of food, but adipogenesis, the ability to store fat and how efficiently, and that's very evolutionary, obviously, from evolutionary biology. We see it in the ability to burn up energy. So one thing I was taught as a dietitian was metabolic rate, that some of us are very efficient at burning up energy. And that is absolutely true. And that is also driven by genes, and not some it's around what we call sedentary metabolic rate. So just kind of sitting around, but for others, it's an exercise. So you can have a look at some really extreme endurance events and still find people who are quite overweight or obese doing endurance events that despite the extraordinary amount of exercise they're doing, they're just not burning up the calories. So that's another way it can manifest. So there's genes that are involved in all these biochemical pathways, which are changing how we're responding. So when you're working with a patient, you don't want to just say, well, what are you eating and how much are you exercising? You actually want to understand all the things I've mentioned: appetite, hunger, satiety, storage, expenditure, burning, all those things, to really get a sense of what is that reality. So, and they've shown this in some fantastic studies where they've put them on like the same weight loss program, same calories in, same calories out, lots of exercise for 2 years, 24 months. And at the end of it, they divided into 4 groups because they lost weight so differently. They gained weight so differently. And in the one group, they never even lost weight, despite the fact that they were on reduced calories and increased expenditure. So we really know this to be true.
If you like this podcast, please click the link in the description to subscribe and review us on iTunes.
That's really interesting. So what are do you have like a list now? So when someone comes to you, do you first have them sequenced, and then based on their particular makeup, you can tell them what kind of a diet might be more successful for them?
Yeah, absolutely. So I build genetic tests. That's what I do. I mean, that's my current company, 3x4 Genetics. And in this genetics test, where we test for 134 genes, but across activity, health, systems, energy. So I was just talking about only one piece, 1/6 of the whole test. We do a cheek swab, we send it off to the lab, we come back. I only work with practitioners, so you can't buy my test direct to consumer. It's got to be through a trained practitioner. And they'll sit with you and say, like, why did you come here? What are you looking for? What are your goals? And then they'll analyze your genes, exactly the kind of things that we've been talking about, and share that with you and explain to you, and then try to figure out, well, what is our action plan now? Understanding what we know about you, what is the kind of things that we're going to decide to do moving forward?
Oh, so what are some examples of advice that you've given, anonymously, but what kind of advice have you given and what was the effect?
So sometimes the advice is, so I've had, people who come to me, it's like, I've been dieting my whole life. I've never been able to lose weight. I'm so desperate. I'm trying this. And when we look at it, we find that in that particular individual, I've had people where their genes are really, really against them. So they would have been great on the savannas of Africa, the kind of hunter-gatherer, but they are really efficient at storing. So what we do is we work with, okay, well, what is a weight you can live with and what's going to be a healthy weight? Because you're never going to be slim and you're never going to have a low BMI. So let's think about what is that weight. Then let's look at your health parameters, and we want to keep you really healthy and functional. Other things, like I've had people come who were training for these ridiculous endurance, like running events. And when we really got down to it, they were doing it because they wanted to manage their weight. But when we looked at their genes, in fact, that was the least effective way for them to manage weight. So they were like, well, I'm not going to carry on running these like tens of millions of miles when that's not. And they stopped it and turned to more of Pilates, functional training, and did a whole lot better. So those are just some small examples. There's also people who come to me and say, look, I've been battling to lose weight. I think it's my genes. And we do the genetic test and it's absolutely not their genes. And we're like, okay, let's try to figure out, maybe there's toxins in your environment. Maybe it's a detox issue. Maybe it's inflammation. Maybe it is not reading the right foods for you. So it's not always like, oh, genes are the problem. Let's try to work around them. Sometimes actually the genes aren't the problem, and let's try to figure out what's really happening.
Oh, that's interesting. So what are some of the major modifications that genes cause in a person? Are some people they're going to store calories much more than other people? Or like, what are some of the major, effects of these gene modifications?
So none of these genes by themselves are so like dramatic that they cause disease or that they, stop you. So there are genes that, if you have one gene variant, you'll become obese, like from a very young age. That's not what I'm testing. What I'm testing is a whole lot of genes who in small incremental amounts will change your biochemistry. So they will change exactly so genes around leptin. Leptin is one of the most important genes around how fat is stored and how you gain weight. And leptin receptor is another gene which works the other way that is very important. We look at things like addiction genes that you can actually, addiction is really an interesting thing, which is very, very genetic. And in some people, addiction manifests as eating and overeating and binge eating. And some people it's alcohol, and some people it's gambling. So we can those genes will change your brain chemistry, where you're looking to upregulate dopamine and serotonin, your brain messages all the time. And there are different ways of doing that. So for some people, you'll try and switch on your dopamine through eating, especially carbohydrates and sugars. Some other people will do it through alcohol. So those kind of genes can have a severe impact on eating behavior. And it's really driven by by neurochemistry, really neurotransmitters. Others really are about the ADRB2s and ADRB3s as your adrenergic receptors, which are really about switching on that metabolism, switching on the ability to be able to burn up calories, where the gene isn't switching on, isn't making enough of the protein that's going to be able to do that. So by themselves, there's not one gene that results in overweight obesity, but it's these small changes when you look at them all together. And then obviously, what are you doing in relation to your lifestyle? So what is your diet? What is your lifestyle? Your stress, your toxin exposure. So we don't just look at genes in isolation. We're still looking at them in the context. Trauma is another one of everything that you're doing in your lifestyle.
So any case studies, without names, of really interesting people that you've run into that you've been able to help? And what was the underlying reason?
Yeah, I mean, it's exactly the same. I mean, lots of people, we've been doing this. Well, I've been doing this for 20 years. We ran a clinic for 4 years where we only saw patients if they did a genetic test. And it's exactly that. We've been able to figure out where the triggers are. So if the trigger is around the appetite genes, the hunger genes, then we build a diet plan specifically around managing hunger. And that can be done in how often you eat. It can be done in the kinds of foods you eat. There's also some brilliant supplements. There's some fantastic herbs you can use that try and manage hunger. So a lot of behavioral work that has been really successful. So we've had lots of patients where we've used behavioral therapies to try and manage eating behavior when we can see that the brain biochemistry is driving them to eat with the dopamine and serotonin. You might want to, we often brought in a psychiatrist or a behavioral therapist to help build more behavioral changes around triggers. And then obviously there's certain foods that would also trigger that refined carbohydrate sugar. So how do we manage that? We use a lot of herbs. So I can't think of any one because I actually haven't seen patients for a few years. And I mostly build genetic tests and teach most of my work. But we've had a lot of success in those kind of patients.
When you say you build genetic tests, what does that mean? Like what's involved in building one? And
so I have a company whose job so I build genetic tests. So I decide, well, not just me, but what we want to do is we want to have a look at the scientific literature and we want to see where are these what we call gene variants or polymorphisms. These are these spelling changes in our DNA sequence that we're born with, that we inherit. What are the ones that are in the scientific literature that are best researched and most clinically useful that I would want to put into a genetic test? So I have a team of 5 geneticists that work with me that we review all the scientific literature to find what are the genes that will change my decision making as a doctor with my patient, as a dietitian with my patient. Then we built kind of a methodology, like an algorithm, to be able to see, is the science good enough? Will they kind of be good enough to include in a genetic test? And once we've decided what all those genes are, then we start figuring out, okay, if we're going to include them in a genetic test, and you, Richard, are going to come to me as a patient, and you're going to do my genetic test, what is the kind of advice that I'm going to give you based on your genes? So I have a clinical team of dietitians and doctors where we work out. So one team decides what is the good science that I'm going to test in this lab to give you? And the other one is, now that I've got these genes, what is the clinical advice, the diet, the lifestyle recommendations, the supplement recommendations? What are those recommendations I'm going to give you? And then we build a test, and then we train and teach practitioners how to interpret that test and use it with their patients. So that is predominantly my work now, which is teaching practitioners how to integrate genetics into clinical work, which they don't learn at university in any way, irrespective of what their degree is. And the other part is, as I say, is building a genetic test. So I have this company, 3x4 Genetics, and we have a test that finds out all these things that I've been talking about you.
So what are some of the new tests you're building? And, you've been doing this for a long time. So what's new about it to you?
So what's new is over my 20 years is that about 4 or 5 years ago, I realized that one of the fundamental mistakes that I had been making, and that pretty much every genetic test I had done, but all other companies had also made, is that they would analyze these genes and they would make a recommendation just on a single gene, pretty much where we started out, which is, say, I told you about this gene FDO, and you have the variant, which means you're going to binge eat. And then they would give you a recommendation and give you a supplement. But actually, I realized about 4 or 5 years ago that science really wasn't accurate, that you cannot make a recommendation on a single gene. You actually needed to look at the ecosystem of all the genes that were in the biochemical ecosystem. So what was happening? So let's talk about glucose and insulin. What are the genes that drive glucose and insulin in your body? You can't test one and make a recommendation. You actually have to test all of them. And then you have to build what we call a polygenic risk score. So where you score each one of them into a total score. So you will come to us, you will do a test, we will test all your genes, and you will actually get a score for every biochemical pathway. And this polygenic risk score methodology was a completely new way of doing things in the genetic testing space. So no one had ever done that. They'd only done like 1, 1, 1, 1, where I realized was much truer to how the body works, which is this aggregating genes in a biochemical space and so that's been a lot of my work in the last couple of years, is how to build a new scientific methodology that was actually much more closer to how our body works, rather than this idea that one gene could actually have the answer for you to what you should do.
Well, very good. Where can people find out about your company and to set up, to speak to their doctor about getting a test done?
Yeah, sure. So it's 3x4genetics.com is the company. You can always email info@3x4genetics.com. We have practitioners around the US who have been trained, mentored, and been through education. So if you just contact us, you can share a little bit with what you're looking for, and we'll make sure that we put you in touch with one of our network who knows how to work with the tests and is able to sell the tests and knows how to help you in the best way possible.
Okay, very good. Well, yeah, thank you for coming on the podcast. I really appreciate it.
Great. Thanks, Richard. Thanks so much. Have a good day.
Bye.
If you like this podcast, please click the link in the description to subscribe and review us on iTunes.
You've been listening to the Finding Genius podcast with Richard Jacobs. If you like what you hear, be sure to review and subscribe to the Finding Genius podcast on iTunes or wherever you listen to podcasts. And want to be smarter than everybody else? Become a premium member at findinggeniuspodcast.com. This podcast is for information only. No advice of any kind is being given. Any action you take or don't take as a result of listening is your sole responsibility. Consult professionals when advice is needed.